There are two major types of compound inequalities. There's absolute value inequalities and there's regular compound inequalities. But they're either going to be and inequalities, where you shade in between 2 points, or they're going to be or inequalities, where you shade towards the extremes. For a compound inequality that has the words in it, that's pretty straightforward. But in an absolute value inequality, it's your responsibility to know what that's really asking you to do. And so in this case, we want to say, okay, I want my distance from 0. Remember, the absolute value is the distance from 0. I want the distance from 0 to be less than 11. So let that sink in for a little minute. We want that our distance from 0 to be less than 11, which means we can start at negative 11 and go to positive 11, but it has to be between those two things. This is an and inequality. Sometimes we remember it as a less and, because you would read that as less than. So in order to talk about an and inequality, I would write this as negative 11 is less than, and then I drop my absolute value bars because I've accounted for both options. Negative 2x plus 5 is less than 11. So then I would solve this compound inequality by subtracting 5 in all three sections here. I get negative 16 is less than negative 2x is less than 6. Then I'm going to divide by negative 2. And since I'm dividing by a negative number, I'm going to put a little star next to it, I've got to switch the directions of my inequalities. So I'm going to get 8 is greater than x is greater than negative 3. So on my number line here, I'm going to put negative 3, and I'm going to put 8, and I'm not going to worry too much about everything in between. I've got an open dot at each, open dot, open dot. I know that negative 3 is smaller than 8, so I have to get them in the right order. And because it's an and inequality, I'm going to shade towards the middle. For number 18, before I start worrying about the compound inequality, I want the absolute value to be by itself. So the first thing I'm going to do is I'm going to add 7 to both sides, and I'm going to rewrite this as the absolute value of negative 3 plus k needs to be greater than or equal to 10. Now, that's saying that this distance from 0 needs to be greater than or equal to 10. So this is more extreme. We want to be further from 0 than 10 is. So we could be past positive 10 or to the left of negative 10. This is an or inequality. So when I write this, I'm going to write this two ways. I'm going to keep the first one, negative 3 plus k is greater than or equal to 10. That's coming straight down. But for the other one, I'm going to write negative 3 plus k. I'm going to switch the direction of the inequality. It's less than or equal to, because I want it to be on the other extreme, and then I'm going to use my negative 10. So for both of these, I'm just going to solve. I'm going to add 3, add 3, add 3, add 3, all the way across here. I get k is less than or equal to negative 7, and k is greater than or equal to 13. So again, I'm going to kind of fudge my number line here. I've got negative 7 and 13. And again, I don't really care about all the stuff that's in the middle. Both of these are going to be closed dots. So I've got a closed dot here and a closed dot here. And it's an or inequality, so I'm going to shade to the outside here. Outside to the right and outside to the left. For both of these, I could write in interval notation, so I'm going to do that as well. For number 17, my first solution is at negative 3, but it's an open dot, so that's not included. And my last solution is at 8, also not included. So I'm going to close the bracket, or close the parentheses. For an or inequality, my solution is here. The compound, or the interval notation is a little bit more complicated. If I read from left to right, at the left I start at negative infinity, so that gets a parenthesis because you can't get to infinity. And it stops at negative 7 with a bracket because the negative 7 is included. And I get an or. And then as I keep reading, the next place where I have a solution is at 13, and 13 is included. And then from there we go on to infinity. And again, I'll put a box around that. So for each of these problems, I solved the absolute value inequality by determining whether it was an and or an or. I graphed the inequality, and then I wrote my solution in interval notation.